Alright, in this last video on graphing rational functions, we're also going to build a rational function. We're going to do that with a couple of different times, a couple of different pieces of information. So, what we're going to talk about here with this function are holes in rational functions. So let me go ahead and write this with the denominator in factored form so that you can see an interesting feature of this function. If I factor this, I've got x minus 4, x minus 1. So you notice that we have the same factor in the numerator that we have in the denominator. That's going to cancel out. And then I'm going to be left with 1 over x minus 4. Alright, well let's graph this function. Now this one is a takeoff of the parent curve 1 over x, and it's just 1 over x moved 4 to the right. So 1, 2, 3, 4. Here's my new vertical asymptote. My original asymptote is at y equals 0. And because it's a takeoff on the y equals 1 over x curve, I know that my function is going to hug these asymptotes like this. Over here, and hug this one like this. Alright, but we have a new interesting feature, and that is this hole at x equals 1. This represents a hole in my graph. So if I come over to x equals 1 and I go down to my function, I really am not going to have a point here. Instead, I'm going to have a hole there. Now, if you were to graph this on a graphing calculator, the hole would be difficult to see, if not impossible to see. But if you would look in the table of values, or just set the table of values up so that you can see what y is when x is 1, it would give you an error message. So you would know there is a hole right there. So some of our rational functions are actually simpler functions. This is a much simpler function than the original appeared to be because there is a hole, and that's a factor that is canceling out of our function. So let's talk about now how you build a function from information. Let's suppose that I tell you that the x-intercept is 1, 0. The vertical asymptotes are x equals 3 and negative 2. The horizontal asymptote is y equals 0. And there's a hole at x equals 5. Let's build the function that represents that information. Well, we know that we get the x-intercept from the numerator, only from the numerator. So when I set the numerator equal to 0, I get that x equals 1. And if I go backward from x equals 1, then I have x minus 1 equals 0. So this has to be one of my factors in my numerator. Now my vertical asymptotes come from my denominator, where the denominator equals 0. So I have two of those. I have x equals 3, so that came from the factor x minus 3, and I have x equals negative 2, which would have come from the factor x plus 2. So I have to have these factors in my denominator to come up with those two vertical asymptotes. Now, this hole at x equals 5 means that I have a factor in the numerator, x minus 5, and a factor in the denominator of x minus 5. That when I graph the function, I will cancel these out. And then we see that the horizontal asymptote is y equals 0. Well, that's true because the degree of the numerator is squared and the degree of the denominator is cubed. So the horizontal asymptote will be y equals 0. So I have just built a function that has these characteristics. Now, it isn't the only function with those characteristics, but it is the function that I have built here. Now let's do one more. Erase my graph here so that I have room. And let's say that I have an x-intercept of negative 2, 0, a vertical asymptote, x equals 1, a horizontal asymptote, y equals 3/2, and a whole at x equals -1. All right, so from the x-intercept, again, if I work backward, so x equals -2, that's my x-intercept. Well, if I put this over here, then I have x plus 2 equals 0. So x plus 2 must be in the numerator of my function. I have a vertical asymptote of x equals 1. Well, I get that from the denominator. That means x minus 1 is a factor in my denominator. I have a whole at x equals -1. Well, I would get that from a factor of x plus 1 in the numerator and the denominator. Remember, your whole has to be in both places. And the horizontal asymptote is y equals 3/2. Well, that's the kind of asymptote I would have when the degree of the numerator and the degree of the denominator are the same. Well, you see, I do have like degrees here. So all I'm going to do is put a 3 on the top and a 2 on the bottom. And I have a function, we'll call it h of x, that I have built from this given information.